What's the state of ClojureScript today? A lot of things have changed in the past 2 or 3 months. There's a lot of new stuff. Unless you read every single post, you might have missed a few of the things. So we're going to sort of cover that today. And then I think Alex is going to do the same for Clojure as well. So what's new? There's a bunch of stuff. ClojureScript is not small anymore. I think, I think the original ClojureScript compiler, when it was released, was like, I don't know, 500,000 lines of code. So ClojureScript, the standard library, is now 10,000 lines. The compilers and the REPL support's also 10,000 lines. So it's about 20,000 lines of code. It does a lot of stuff, and it's probably going to do more stuff in the near future. What are the things that it does, and why is it grown so much? Lots of stuff to talk about. One thing that's huge is that for a long time, for various reasons, because we were focused on just getting things working, the compiler was probably not as fast as it could have been. So if you've messed around with the cljs.jar, which is like the standalone thing that we have now, things are really fast, and eventually they'll also be fast if you're using even Leiningen. The main problem is that since the compiler is really 10,000 lines of Clojure, every time you run it, we actually have to compile 10,000 lines of Clojure every single time. So we want to stop doing that. So things that make quite a bit faster today, we have a lot of analysis caching. We cache the results of the compiler. We just skip analysis completely. On my work desktop now, if I compile Hello World cold JVM build, it only takes about 1.5 seconds. It's way faster than it's been in the past. We actually, a big reason it was slow is because we would also, not only would, when you load it up, are you compiling 10,000 lines of the compiler, you'd also compile 10,000 lines of the standard library. And we don't do this anymore. In the jar, at least, we ship, in both cases where we ship the entire standard library pre-compiled. So it's really fast under dev. And it includes the source map as well as cache analysis. Eventually, even if you're using Leiningen or boot, and you're not using the Uber jar, it will still be fast because we're going to start shipping basically AOT'd artifacts. It's already true for ClojureScript's dependencies. So if your tools reader and data.json are actually available as AOT'd Clojure artifacts, you can actually just add a classifier AOT, and you'll get that already precompiled jar. Okay. CLJS jar, it's pretty cool. It's really not, you probably won't be using it if you're using boot or if you're using line. But if you're like trying to show people that ClojureScript's neat or interesting or fun, it's a lot simpler to get started. You don't have to explain Leiningen or introduce them to some other build tool. You really can take this one jar, as long as you have Java 7 or Java 8. It's probably better with Java 8 because Java 8 has NASForm, but it does work with Java 7. That's all somebody actually needs. Again, this is great for beginners. The entire quick start, which is the entry point for people who have never really looked at ClojureScript before, all the instructions are around using the single jar. There's fewer moving parts, but it's also better for the broader ecosystem. So as there's so many cool tools that are coming out, Figwheel, you've got Amelie, which we'll talk about, bootcljs. There's a lot of interesting stuff happening. But it makes my life harder and the people that work on the compiler harder because without this separation, it's confusing as to where's the problem. Is it downstream or is it actually in ClojureScript itself? And CLJS jar is a great way to say, I'm going to submit an issue or a bug, show that you can reproduce it with this. Don't involve any other tooling. It makes it much simpler to find the source of the issue. So Foreignlibs is brand new, and this has totally exploded in a very short amount of time. In 3 months, people are really using this. So it really simplifies the story of there are a lot of interesting libraries out there that aren't written in ClojureScript, right? React is awesome. ClojureScript developers love React, but it's not written in ClojureScript, and there needs to be a good way to include it in your build, and this is what Foreignlibs was designed to solve. Also, for various reasons, you might be, I want to use jQuery. I want to use jQuery UI. And those are dependencies. They have to be put in a certain order. There are lots of problems to solve. And again, this is what Foreignlibs lets you do. It also lets you escape from extern's hell because with Foreignlibs, you can produce a jar that has all the Foreignlib information, including the externs so that people that want to use a plain JavaScript library, they don't have to define any externs. And then, again, this allows the community to package useful libraries that, again, just aren't available for in pure ClojureScript. CLJS is probably the best way to consume one because it's curated. There's a lot of support. It has 33 packages now. Google Maps, Dimple, D3, Pick-a-Day, Moment, React with extras, and so on. It's great. Really just solves that problem of wanting to use a popular JavaScript library that, again, can't really be a part of the Google Clojure compilation pipeline. CLJS tests is new. For a long time, the community relied on Chaz's pretty nice ClojureScript test. The problem with ClojureScript tests is that it was oriented around simple or something higher than none, which is kind of not that fun for having a really productive, fast development workflow. So CLJS test is official. It works with every compiler, a setting you throw at it. It's worth checking out. We dogfooded it on our own tests. So there's like 16,000 assertions that we run when we test ClojureScript, and these are all written in terms of CLJS test. Most of the functionality from Clojure test has been ported, so it really is designed, if you're familiar with Clojure.test, it just works. Again, works under optimizations none. It has async testing support, which we've already dogfooded on core async. There are a couple bugs because it's relatively new stuff, but it works reasonably well. Static VARs. So when Rich first announced ClojureScript, we're getting rid of VARs because we're just going to generate code that makes sense to Google Clojure, and including reified VARs really didn't make sense. And so for a long time, we didn't have anything like VARs, but actually we do now. Because when I ported Clojure test uses VARs not in any dynamic way. It uses in a very static way to get metadata about a namespace, like what are all the VARs with tests attached to them. And so we support this now. A subset of the VAR abstraction is available specifically to support testing, but you can use it as well if you want to do some sort of metaprogramming. It's a very simple way to basically grab compiler information without being a compiler expert, right? If you want to get the source or a line or the arg list or what have you, you can do this now. It just works. And the static VARs are invocable, same as they are in Clojure. Macro usage has gotten simpler, and it's probably going to get even more simple in the future. But basically, there's new convenient behavior. If you consume Ohm or any of really a lot of the nice React wrappers, they do this little trick where if the namespace and the macro namespace are exactly the same, and the library namespace includes the macro namespace, downstream users can just require the namespace. They don't have to talk about the macros. They can just say require ohm.core and alias it as ohm, and that's going to pull in both the macro NS and the library NS, and it just works. And that's pretty nice. Tons of updates and fixes around incremental compilation. We always sort of supported incremental compilation, but it was easy to corrupt your build. Specifically, if you have a parent namespace and a child namespace, you change the parent, that wouldn't necessarily trigger a recompile of the child namespace. So we recompile dependents now, and it's awesome. So if you change a parent namespace, we find all the child namespaces and recompile them. This is huge for testing. So often you'll have a bunch of test namespaces and then one namespace that calls run tests. And you really need that to get recompiled because of the static VAR thing, right? If the VARs are static information, you have to recompile the run test thing because that expands out into all the VAR references. So this is great for testing. You can change a test and your test runner namespace will get updated, recompiled. And again, this works even under cold builds. So if you're just running a cold build, it still works. If you want to disable it, if you're a fan of Figwheel, this behavior, while it's great for correctness, may be kind of annoying if you're using Figwheel because you kind of just want to sort of play fast and loose because you're just deving. You can disable it. There's a flag for it. This is big. This is mostly for people who are shipping large ClojureScript applications, which I have seen quite a few now. What you want to do is you have a single build, but you're really like, your build is now quite large. You're relying on React and you're relying on Ohm, and you have your own libraries and you have 15,000 lines of ClojureScript. And you're like, we really need to divide this up so we only load what we need on each page. So Google solved this problem back in 2011. It's just never been exposed to ClojureScript in a reasonable way, and I went ahead and fixed that. So if you do an advanced build, you can now code split it, and it's actually really awesome. It's actually quite a bit more sophisticated than anything that's available for JavaScript. I think this is one of the neatest features for people building large applications. It allows you to build the product. It's really one build, but allows you to split them into optimal pieces. It has nothing to do with ES 2015 modules or AMD modules or common JS modules. When people talk about those modules, they're talking about something that a human writes. Google Clojure modules are only about code splitting. So one thing that we tweaked around this is that it used to be that the top level was a little bit too dynamic, and Google Clojure couldn't just arbitrarily move functions. So the standard library is big, right? It's 10,000 lines of code. And so what I did is I changed the top level so that when we emit functions, everything is static. The top level is always completely static. And this means that even though we have a large standard library, Google Clojure can actually move code to where it belongs. So even though it's huge and one big thing and monolithic, Google Clojure can say, oh, you only use, say, partition. It only is used in this namespace. It will actually move partition into the namespace where it's being used. And this is amazing. There's nothing like it for JavaScript yet, besides Google Clojure. So ClojureScript emission is optimized for this. So you don't have to do anything. There's absolutely nothing for you to do. You're just getting this for free. Again, FNs will get moved to where they're needed. This is big. It only took 3.5 years to get to this, conditional reading. So I didn't work on it, so you'll have to thank Alex Miller, Nicola Mametto, who's known as Bronza, worked on it. Luke Vanderhart worked on it. Alan Dipert and Micah, I think. They're the ones that really pushed this in the right direction. We would have ended up something that was really not data-oriented. And I think what we ended up with was actually really, really cool. I like it quite a bit. You don't have to use CLJX. Basically, you can write your source files that need to be shared. You need to feed it into the Clojure compiler or the ClojureScript compiler. You just use a new extension, the CLJC. It can be loaded by both compilers. We support 3 platforms. We need feedback. Try it out. It may be the case that we need to extend it in some way. But right now, out of the box, it works for Clojure CLR, Clojure, and ClojureScript. It also works in REPLs, so if you're a library developer, it's really easy to use. You can be in your CLGC file, and the REPL will be configured whether you're in Clojure and ClojureScript, and you can eval and all this stuff. It's just going to work. Like when we shipped it, within 24 hours, people had already ported their CLJX usage to it. So it works. It's quite useful. The other big news is REPLs. So for a long time, because we were focusing on basically allowing people to ship really production artifacts, we didn't spend as much time on REPLs as we should have. They were really woefully just wrong. They just did not work at all. And it's required a lot of breakage, and I apologize for that. But I think in moving in the next 2-3 months, whether you're in Vim or Emacs using Cider or you're in Cursive, REPLs will work, and they'll work exactly the way you've come to expect from Clojure itself. There's a bunch of new REPLs, which is really awesome, and I think you'll see more of this in the near future. We ship out of the box a Nashorn REPL. The Nashorn REPL is interesting. It's maybe not the one you want to use unless there's a specific reason for it, but I'm hopeful that by Java 9 that a lot of the load times issues will be fixed. But the nice thing about Nashorn is that it's comparable to modern JavaScript engines like V8 and JavaScript Core, so that's cool. We have a Node.js REPL, so a lot of people like this. It works pretty well. It could be made better, so if people are interested in enhance, let us know or submit a patch. The nice thing about the NodeRepple, it is actually reflective of browser JavaScript performance. So the NodeRepple is actually really great. I use it, for example, to dev test check. So when I ported test check to ClojureScript, it was a really great way to just fire up the NodeRepple and confirm that the behavior of test check was the same. Again, the REPLs got overhauled. Like basically everything works, whether it's doc, source, dir, print stack trace. The stack trace will always get remapped back to ClojureScript source. Macro expand works, require works, NNS works, load file works. Specifically, load file is really important because that's what a lot of the tooling uses to trigger a recompile and a reload. So for example, I actually use, when I'm in Emacs, I use inferior Clojure, which is from the Clojure Emacs team. And it's the same mode, right, as the Clojure mode. And I can interact with a ClojureScript REPL in exactly the same way. It just works. Again, all REPLs support stack trace mapping via source map. So it doesn't matter if you're in the NodeRepple or the Nastran REPL or JavaScript core or whatever. You'll always get a ClojureScript stack trace, not a JavaScript one. The support that we did, so not only did we overhaul everything and all this stuff works, it's completely generic. I highly recommend checking out Figwheel. So Figwheel is a custom REPL that supports all these really cool behaviors, and it's built on this reusable architecture that we've set up. Another one that's super exciting is the Amelie REPL for iOS, and I'll talk a little bit more about that in a second. The REPLs now conform to the same design as ClojureMain, which is really good for integrating with NREPL or CIDR. It's perhaps not the best design, but it's really, again, this is what NREPL expects. Piggyback 2.0 and NREPL 0.9, which are just on the verge of coming out. They're snapshots, but it's probably really soon will deliver basically CIDR will just work for ClojureScript, which is huge. So let's see a demo. So I'm going to show this with IntelliJ, but all of this will work with anything, really. So here I am. Here I have a REPL over in the side. If I can go Control K, and here I can switch into this namespace. I can type foo, and I'll see the function. Type Clojure West. Right, that works. This is it. You should notice up here, does it not say? This is actually, I'm actually in a .clj file. This is not a .cljs. So a lot of things that didn't work in the past work now. So oops, does that work? Oh, sorry. So I'm in the wrong namespace for this. Let's go back. CLJS user. So if I want to get the doc string for first, that works. If I want to get the source for first, that works. If I want to find, for example, I want to find doc, anything that mentions, this is a regex, anything that mentions the word array, right? So it really now, instead of feeling like, second class to the Clojure REPL, it's really exactly the same. And pretty much everything works. Another cool one that I added. So debugging macros was never that fun in ClojureScript, but here I'm going to macro expand. Does that work? Yeah. So macro expansion also works. That's pretty sweet. Okay. Other exciting stuff is that when Rich first announced Clojure, one of the big goals at the time in 2011, the obvious target was the web, right? It was just the web. It was that JavaScript runs in the web, and we want to build web apps, and we want to write Clojure. We don't want to write JavaScript. And it's not that there's anything wrong with JavaScript, but we like Clojure. And we would prefer those semantics and the benefits that we get from Clojure, even if we're targeting client-side stuff. Things have changed quite a bit thanks to React. So the nice thing about React is that React now has a developing story for native. And how it's going to work is basically Apple itself has been improving the JavaScript core bindings. You can even create basically multi-threaded JavaScript applications. So they haven't publicized this, but the JavaScript core support is very, very good. And what Facebook said is, okay, what we're going to do is we're going to make a huge set of widgets that are standard widgets, and we're just going to write the entire application in JavaScript using the React rendering model. It's great, but this means that for ClojureScript users, you now have a story that's going to be done pretty soon, which is that if you want to target the web, you want to target iOS, you want to target Android, you can do this all in ClojureScript and React. And this is huge. There's not been a way to do this previously in the past. So a huge step in this is this REPL called Amelie, which is by Mike Fikes. He actually is already shipping an application in the App Store written purely in ClojureScript. It doesn't use React, but it uses the same tricks. But here, I totally recommend checking it out on GitHub. It's called Amelie. It's hosted under the Ohm organization. And it basically lets you dev live against your iOS device. You don't even need Xcode. You can basically boot the app with the REPL, and you can actually compile JavaScript sources directly to it because you can basically mount it as a WebDAV volume. It works great. And if you haven't tried it, I totally recommend giving it a spin. It's super, super fun to be able to interact with an iOS device directly with Lisp. So yeah, so keep your eyes out for this. Check it out. Amelie, again, it just uses Bonjour and WebDAV, and you can automatically connect to your device. It's definitely a good foundation for React Native integration. So what's next for ClojureScript? So that's sort of a bunch of updates. What are we planning on for the rest of the year? A couple things. So we really want tooling to be stable and be better. I mean, this has been a problem because ClojureScript moves so quickly. And often, people just tap into details that really we've never discussed or they're not public. So we want to fix this. We want people to have something that's stable, that we run tests on, and that's where we meet. People will need to stop calling into the implementation namespaces. So this is already under development. The two namespaces that we have are CLJS build.api and CLJS Analyzer API. So if you want to build some really amazing tool, you'll want to go through these in the future. If there's something that's not there, ask us, and we'll figure out what exactly is required and needed. But relying on this will stabilize things for everybody. These namespaces will get dog-fooded, so we're going to actually use these ourselves as well. It's not just going to be like, oh, we think this is what people need. We'll verify that, and then hopefully it will get better over time as people describe what the gaps are and what's missing. Optional bootstrap is also going to happen, and it's really likely we won't actually do this ourselves. We're not going to get in the way of it. So now that we have conditional reading, there's almost nothing left to do. We just need to port some macros. Somebody needs to port tools reader to compile to Node.js, and that's it. You can point the compiler back at itself. And if you want to do that, you can. And there are legitimate use cases for this. There's some interesting new targets, right? Back in 2011, these targets didn't exist that would benefit from a bootstrap compiler. Atom Shell is an obvious one. So there's a lot of people building desktop applications, portable desktop applications with Atom Shell. And this would be great to just be able to stick the compiler inside so that when you ship your thing, you don't need the person to install the JVM first. So this is a problem for Lighttable, right? So people have to have Java to use Lighttable. With this model, you could just ship the thing. You don't need Java. There's very little left to do, as I said. Port tools reader, macros, and some conditional reading. So now something that's happened, something that got announced right before the conference is the final draft for ES 2015. It's really happening, finally. But it's actually in some sense it creates problems for us. I think it was Rich Hickey once said he just wanted Java to stop changing, and I kind of feel that way about JavaScript. But we have to deal with it. It's happening, and people will start. You'll find more and more code out in the wild that uses ES 2015 modules. It's already the case that we have this problem with React. React ships this thing called React tools, and what people often do is they'll have some really cool widget that they haven't compiled to be used in a normal way. You need React tools to build the thing, and that's a problem. So React.js relies on both a custom transform called JSX, and then on top of that, it uses CommonJS, the CommonJS module format. So we can't consume this stuff, right? And the thing we want to avoid is a world in which you have to run some other build tool in order to get something that you can load into ClojureScript. So we have a solution coming for this. It's a joke, SystemCLJS. If you've heard of SystemJS, it's a similar idea. There are 3 popular module formats. Google Clojure already thought about this, again, back in 2011. Google Clojure can actually consume and process AMD and CommonJS. They just haven't exposed good hooks for it. And I will be submitting some patches to the Clojure compiler to make it easier to work with. And likely we'll start leveraging JavaScript parsing and analysis. So one thing we don't do is we don't often validate the way that you're interacting with JS, and that's going to change. And then likely this will also lead to what we're sort of calling externs inference. So we would actually be able to automatically compute all your externs for you. So this is even better than the existing behavior that you get from Foreignlibs. You wouldn't have to package externs at all. This is important for things like 3JS, right? 3JS is massive. It's huge. Nobody's going to write externs for it. So this would be a way to automatically generate it based on the code that you wrote. So that's it. Does anybody, maybe there's time for questions, or maybe Alex needs to get on. I don't know. Quick questions? Go ahead.
Is there a runner for CLJS.test?
There's no runner. We don't ship runners. Yeah, it's just outside. It's completely outside what the ClojureScript compiler is designed to do. You can bring your own runner, though. Yeah. I mean, it's something definitely to rely on some other tool to launch for you. Other questions? No? OK, thanks.
So I'm going to be talking a little bit just about what's going on in the Clojure world and company world and community world, and just try to catch you all up in case you don't. Like David said, he and I sort of serve complementary roles and obsessively watching things that are going on. So sometimes it's hard for us to pull back and get into the headset of people who are merely just using it as interested developers, but not obsessive people like us. So Clojure 1.7 is coming real soon now. We're currently at 1.7 beta 1, and there's been a number of bugs reported on that, and regressions and little things that we forgot, and almost all of those have been resolved already. And have patches ready to go. And I expect that sort of after the conference, when things calm down a little bit, that we'll move rapidly to release candidate 1. I can't really predict exactly when that will happen, but I would guess within the next week or 2 that we'll probably be moving into release candidate mode. And at that point, when we release things like a release candidate in particular, it's extremely helpful if you can sort of go to your internal project or your library that you have and update it to release candidate 1 and run it and see if there's anything that you don't expect that happens, and then give us that feedback. And that can be, and you can give us good and bad feedback. It's really, really helpful to hear from 20 people, upgraded, didn't see any problems, looks good. That's extremely helpful. So we announce all those in the mailing list, the Clojure mailing list. So if you see that, please give it a shot, and that helps tremendously. Some of the big, I want to mention, these are current contributors. I think there's probably some patches out there with new people that aren't included in this, but I went through the commit logs for 1.7, and these are all people that are included, and it's great to have all of their help. Many of these people, it's not the first time they've contributed to Clojure, and we really do appreciate it. I do want to mention Gadi Shaban probably doesn't have that many lines of code that were committed in this release, but he's been a tremendous help to me sort of offline and thinking through different issues, and I really appreciated that. And also I want to mention Nicola Mamedo, who has done a lot of the work on like Tools Reader and Tools Analyzer and those kind of libraries, and he often wades in on the nastiest, gnarliest compiler AOT related things and helps me make progress there, and that's just been, it's been hugely helpful for him to have him helping out, and so big thanks to him, and to everybody else who's contributed, of course. So there's kind of 2 big features that I want to talk about in 1.7. I'm not going to talk about them very much. This is the entirety of the slides about transducers. I'm obviously skimming the very thinnest bit of surface here, but I do want to give you a little taste of it just in case somebody hasn't seen it yet. The big thing with transducers is that they are composable algorithmic transformations. So that allow us to take the kinds of operations that we currently see in our sequence functions that we use all the time, and to create what we call a transducer out of that. So when you see filter, odd, or map inc, those are just like the normal sequence functions we have, but they have one less arity. So we actually omit the input source, and it just really represents the pure operation of filtering odd over each element in something, or mapping inc over each element in something. And then we can take those things and actually compose them, still completely distinct from the input source or how they will apply it and how the output will be collected. So transducers, if you think of sequence operations as really having three parts to them of traversing some input, performing some transformation, and then producing some output, transducers are really just the middle part. And so we can produce these sort of algorithmic composable transformations and then choose to consume inputs in different ways and produce outputs in different ways and with the same transducer. And so it gives us this little reusable thing that we can use in different ways. So transducers, because they actually form a stack, they actually, the order that you compose them will feel backwards. So that's kind of confusing. It's kind of like middleware have the same kind of a problem. But we can use comp, and comp will work just fine to compose things in a left to right manner. So when we say comp, filter odd, map inc, take 5, that means first take the input and filter odd, then map inc, and then take 5. So it's analogous to the thread last macro or something like that. If you want to, that's how I think about it, and that helps me. And then there's a bunch of ways we can apply that transducer. There's a brand new function called transduce, which is similar to reduce, except that it takes an initial argument, which is a transducer. And so the final argument is the input. We apply the transducer to all of the elements of the input. We apply some final reducing function, which is exactly the same as the original reducer function. And then that 0 there is just the initial value of the final reducing step. So that's how we use transduce. Into now has an extra version with an extra arity. So you'll see that XF in the middle there. We can take the input sequence, transform it, and then collect the results into some other data structure. So this allows us, here I'm using a range, which is a sequence, but you could also use this on a vector. And so you start with a vector and you end in a vector, and that's something that happens eagerly. And so this allows us more options in terms of how we apply the kinds of transformations we're used to getting with lazy sequences and things like that. We have new options now for how we can apply those. And in some cases, doing that eagerly is going to be what we want, right? We know that we want to produce this output at this point, and we can control that. And the benefit there is that because we're able to build this compound transformation, we do that through a single pass over the input. And there are no intermediate lazy sequences being created. And that allows us to have greatly reduced allocation costs through that. And you can really get, if you combine that with a source that knows how to reduce itself, and we've had a bunch of changes related to that, those two things can allow us to avoid a significant amount of the object allocation that we had before, and also do less sort of function operations as well. And so you really get some significant benefits in that case. If you do still want to do things lazily, there's the existing sequence function, which probably most people have never used, but it's similar to seek, except that it will return, instead of a nil, it actually will return an empty sequence, potentially. But that function now also takes a transformation function, and you can consume the input, apply the transformation, but receive those things in a sort of incrementally computed way, a lazy way as you read elements off of that. Eduction takes that same idea. It's something that's not going to be computed at the time that you define it, but it will actually recompute that transformation every time you use that eduction. That's useful in the case where, for example, you don't want to hold on to the head and then have all of the intermediate state of that transformation in memory. So if you just want to do that once and then consume it and let it go away, but then maybe do it again, eduction is a key tool for that. And then finally, core async has been extended so that you can create a channel that will actually apply a transducer to input values that are flowing through the channel. And so you can use exactly the same transducer in all these different ways. So that's the short pitch on transducers. There's a clojure.org/transducers page now, and there's also several talks out there now from Rich and other people that are useful to see how those things work. And there will be some more. I'll be writing some more things about that as we get to the 1.7 release. The other big feature, I think David probably talked about this already, but reader conditionals. And so again, I've condensed this entire months of feature work down into a single slide. So I would echo what David said about thanking the many people who worked on this in different parts, and in particular, Alan and Misha in particular, for sort of driving a really useful design discussion around what we should be doing. So the big thing here is that we have a new file extension, .cljc, where the final C you can think of as common, or a file that's common across Clojure platforms. Inside only CLJC files, you can use these reader conditional forms, and I just put two examples here. The reader conditional kind of should be reminiscent of a cond, so it has a condition at the beginning, which is really a match against the platform feature. So each platform has its own feature, and it's going to walk through those until it finds one that matches the current platform. So it's going to try CLJ, and it's going to try CLJS, and at the point where it finds one, it's going to read and emit the expression immediately following. And any of the other branches will not be read or put out. And it's possible to fall through this and actually emit nothing, not nil, but like literally as if you had not read anything at all. And that's an important capability for some use cases. And there's also the splicing version, which is exactly the same, except that you're expected to turn something that is some sort of list, vectors or lists or other things like that, and the results will be spliced into the outer context. So you could produce on Clojure, in this case, you'll produce ABCD. On ClojureScript, you'll produce ABEF, and on another platform, you just produce AB. And so that's, in a nutshell, that's reader conditionals, and again, I think there'll be more stuff coming out about details of that. Another big focus, and I've worked on a lot of these in particular, is performance. And so we've done a lot of things, and there have been a lot of sort of bugs and patches and enhancement work that's gone on. Some of it is driven by transducers. Some of it would just happen to come into scope for this release. Symbol and keyword construction is faster. We've got significantly reduced compile times, in particular on by reducing class lookups. And this is particularly useful in macro-heavy projects. And Zach Tellman, I think, who's here somewhere, was the sort of the genesis of the ticket that drove this change. And so big thanks to that. It really makes a significant difference in some projects, like 50% faster compiles. In some cases, it will give you no faster compiles. So I'm not saying that for everybody, but in some cases, it helps. There's a number of functions that are sort of generators of sequences. So repeat, cycle, iterate, and range are kind of the main ones. All of those now have different implementations that actually work faster as sequences. So if you're using the way you were using them before, you continue using them in the exact same way, and that is now faster. They also now are reducible, and so those are use cases that work with any of those contexts where we're doing reduce-like things. So that includes reduce and into and transduce, and any of those kinds of contexts can leverage that behavior to do a faster reduce without allocating a sequence and then having to throw that away. And so let's see, hash maps and hash sets. They now have direct iterators. Before, they would create a sequence and then build an iterator over the top of that sequence. You can now iterate the hash map and the hash set directly without ever building that sequence. And this is, again, something that's being taken, that we're taking advantage of this in a lot of the low levels of reduce underneath other things. Keys and vals used to, if you think about what they used to do, if you went to a map, it would build a sequence of map entries first, and then walk through the sequence of map entries and extract the keys from each map entry. And so what happens now is that we're able to actually build an iterator that walks directly over the map and produces that iterates over the keys of the map. So it does not generate all of the intermediate map entry objects because we're not going to use them. It also doesn't generate any of the intermediate sequence nodes because we don't necessarily need to use those either. So that makes things like keys and vals significantly faster in these reduce-like cases. Iterator seek, which is used to wrap a sequence around an iterator, and that's a case that now comes up in some different places, is now a chunked sequence, so that's faster. Vec and set have been completely reworked and are now significantly faster for most inputs. And in particular, there used to be some sort of conventional wisdom about how you should use into instead of vec and set. And into is still really, really fast because it's based on reduce, and it's gotten faster for a lot of these reasons too. But vec and set, in particular for the use case where you're passing some collection in and you want to ensure that it's a vector, vec in that case will recognize that special case and be able to basically avoid creating a new vector to a large part. And the same thing with set. So that particular use case now is something that can return in nanoseconds instead of some linear time related to the size of the vector or the set. So that's a huge win for that particular use case, and it also is better for sequences and lots of other cases as well. We did a little bit more argument unrolling and partial, which is used by other things, and so that helps in a few places. And then we also discovered, this is something I ran into literally years ago before I was at Cognitect, and didn't understand what was happening at that point and just rewrote things until I got past the problem. But somebody else ran into it and posted something on Twitter, and I recognized it, and now that's my job. I said, hey, do you have a reproducible use case for that? And he did, and I very quickly figured out that the default value dispatch case for multi-methods was not being cached like every other case. So it's actually a pretty common thing that happens, and the cache was basically not being utilized for that particular use case. So one place where I've seen that come up a lot and where it actually was reported was using Clojure walk to walk a data structure. You tend to end up hitting the default as you hit some of the intermediate nodes. So things like that particular use case is now significantly faster. There's some other things that I'm not listing. These are kind of the main ones. All of these things combined to make 1.7 really substantially faster in a lot of real-world use cases without changing any code. If you want to use transducers and sort of go down that route, I think there are greater gains to be had. But even if you are not doing those things, we've seen some early, these are some tweets that I've captured from out there. Tom Crayford was seeing 50 to 70% performance improvement on some of the benchmarks that they run in every release. His build went down from 32 seconds to 18 seconds, so he saw a big significant jump there. And then we've seen, these are some production timings here where you can see that it's using less CPU and less resources. And then I've got some other reports too, but I didn't have any sort of good Twitter things for them or anything. But we definitely are seeing real gains from some of these changes that are in 1.7. And I also saw a couple of these tweets recently, and I captured them because it's something that most people don't talk about, but that I spend a lot of time thinking about. But we work really hard to avoid breaking code between releases to make it easy to upgrade, and we're following in Java's stead there for sure. But we do really care about regressions, and we want to hear about those if you see them. And so we want you to be able to upgrade without, in the majority of cases, without having your code break. And we do really spend a lot of time on that. Okay, so that's 1.7. We will be moving into thinking about the next release soon, but Rich and I haven't had a chance to really have a talk about that, so I'm not going to predict that. We definitely have talked about some things, and there'll be more coming on that, so I can't talk about it yet. He was supposed to be here. Maybe we might have had that conversation today, but we didn't have a chance. So I wanted to talk just briefly about sort of companies and the fact that we all make our livelihood out of this pretty much. There's a new page out, new since the last time we had this conference, page out on Clojure, the clojure.org/companies page. I've been adding companies that are using Clojure in some way out there. If you want to be added to it, there's an email at the top there, and feel free to ping me. There's 148 companies on there, which is probably more than I would have expected when I first started putting this page up. I would love to add more companies to that, so please, if you're not on here, check and let me know. We also have a page out on the Cognitect site where we've been trying to collect sort of a little more success stories to give a little insight into how people are using it and why they're being successful with Clojure. There are a number of, I've just kind of grabbed a screen grab of part of this page. There's a lot more to it. So you should go look at that. It's really good if you're trying to convince somebody to use Clojure, to show them that lots of people are really using it and being successful with it. If you'd like to be added to it, that would be fantastic. So please talk to somebody at the Cognitect booth. Jen Hillner is here, and she's been reaching out to a lot of people. You might have gotten an email from her at some point. And so she's here, and she's involved in updating this page. And we can add more things to it. That would be great. I also want to mention, because I don't know that everybody knows this, but Cognitect does a number of things in the Clojure space besides just maintaining the language. We do consulting. We also do training. So I will sometimes go out and do training classes at companies if you're trying to move towards Clojure and train more people. And we also do things like architecture code reviews, and we also sell support contracts for Clojure, as well as the other things that we produce at Cognitect, like Datomic and other things. So if those things are useful to you, I just wanted to let people know that they exist, because what we're finding is people don't know that we do that stuff. So those options exist. Moving on to community. The Clojure community is fantastic and awesome, and so I never get tired of talking about it. Just a quick update on Google Summer of Code. Last summer we had 9 slots that were allocated to us by Google, and we had projects about core typed and Quill and Tools Analyzer and Core Matrix and some compiler ideas and Light Table. And so a lot of interesting stuff, and I think there's 2 people here from the Google Summer of Code, and we were able to use the funds that we can request from Google to get people to conferences. And so some were at the Conj, and there's some here today. We've been allocated five slots for this year, and those are sort of in the process of getting decided. I don't think they've actually been decided or finalized yet, but that should be happening imminently. Opportunity grants. This is something we started last year at the Clojure Conj, and the idea is to remove obstacles for people of underrepresented groups, really with the idea of improving the diversity of the Clojure community. And I think it's been one of the most rewarding things. And we have a similar program at Strangeloop, which I also run. And this sort of thing has been one of the most rewarding things that I've done in my career. And so I'm really proud of it. And we raised over $10,000 at the Conj, and we're able to bring 12 people in. And at Clojure West, we raised about $14,000. This has 19 on it, but I know that we've had at least 4 or 5 more that were here in town that we were able to get into the conference just in the last day or two. So I suspect that number is probably low at this point. But it is really making a difference, and I just want to thank everybody who has sponsored one of the opportunity grants. That includes a bunch of companies. There's, I think, 4 companies that sponsored in this conference, and that's been on the slide roll that's been going through. There were more at the Conj, and then there's also been many, many individual contributors, both at Clojure West and Clojure Conj, who have donated money as they bought a ticket, and it's hugely helpful, and we've been able to, I think, really make a difference with that stuff. Clojure has never done anything like that. Oh, thank you. Clojure has never done anything like that. We announced a little bit back that we've taken over the organization of the Clojure conference and are working on that with Marco, who's run it in the past. And we expect to have an opportunity grant program out there. We just haven't, we're kind of waiting to get through this conference before we announce all that stuff. But we'll be definitely accepting applications for that, and we're already have some things out there for sponsorship, and we've already had some sponsorship dollars come in, or euros actually come in. So we're still adjusting. It's really terrifying to run a conference out in a different country, by the way. But anyhow, so that's an interesting thing. Clojure is going to be June 25th and 26th in Barcelona. If anybody's interested in making a trip, should be a great conference. I want to mention some of the books that are coming out. I probably forgot some, and so I apologize for that off the top of my head. There are, I know a number of the authors are here in the audience. So I know Karen Meyer is here with Living Clojure, and Colin Jones is here, who wrote the Macros book. I happen to have a book that just came out in Pragmatic Press. And I don't know if Daniel Higginbotham is here, the author of Clojure for the Brave and True. He might be, but I'm not sure. And I don't think any of the other authors are here, but if they are, I apologize. And if I missed any other books, I apologize. But these are all books that have come out since Clojure West last year. So that's awesome, and I know there are more sort of in the pipeline. So it's great to see lots of interesting books coming out, things to read. I also want to talk about Clojure Bridge. Clojure Bridge was just sort of in its infancy at Clojure West last year. There were some meetings that happened here, and it had already been sort of underway, and planning was underway for the first one, which was in Durham, North Carolina. And so just to give a little update on that, about the things that have happened since then, there's been, I'm missing a couple of them on here. There were events in, I think, one more event in Minneapolis and one in San Francisco that I think I'm actually missing on this slide. But there's been about a dozen Clojure Bridge events since then, including 2 this past weekend, one here in Portland and one in London. And so that's just phenomenal to bring people into the community. Again, like the opportunity grants, I think it's really making a difference. Could I ask anybody who has helped organize, TA, or attend at Clojure Bridge? Can you stand up? I don't know how many people are here, but probably a lot. So yeah, awesome. So if you're interested in holding a Clojure Bridge in your area, please get involved on the mailing list, and there's great resources now for helping to organize TAs and teach and materials and all those things. All that stuff is really been pushed forward by a lot of great people who've done a lot of work. So that's awesome. Playing with Keynote, you know. And then I also wanted to mention some of the Clojure Bridge sponsors. These are all people or companies that have sponsored Clojure Bridge at some event over the past year. And so there's a huge amount of people. I'm sure there's lots of people in this room that work for one of these companies. So thank you to all of you for supporting these efforts. It's greatly appreciated. And that's it. That's all I had. So it's awesome to be here and to see the growth in the community, and I think there's just fantastic things ahead for Clojure. Things are definitely on an upward trajectory right now. The one other thing I meant to do earlier that I forgot to do, I want to see a show of hands of everybody whose company is currently hiring for Clojure developers. So there are tons of people looking for Clojure people right now. So I'm sure there are also people in the room who are looking for Clojure jobs. So you have no excuse. There are plenty of people here. That was about a third of the people here. So talk to 3 people, and one of them probably is hiring. And then talk to 9 people, and you'll have 3 interviews. And then you can find somebody great. So let's match you all up while we're here. and then go make awesome things. So let's keep it going.